It was starting with DL.
Oh. Thank you. That one, right? Okay.
So, possible. Since it's a pass by reference, it's a prefix.
Yeah, it has to do with how they're used. So for example, you can do this. This expression here, plus plus I, is an L value. Okay, so you evaluate this, and then you can assign it. However, this is not allowed, because this is an R value. And so in order to be able to modify it, or take the address of it, or do all sorts of other things, you have to return a reference. You have to have a real object there, not just a value. If you didn't do that, life would go on, but you wouldn't be able to use it as the same way that you use integers or floats. You could return a float, you wouldn't even have to return it. They're totally up to you how to define the loaded operator. All right, good. Over, right? Let's go on. So, oh, yeah. I know. Arrays. Should be relatively easier. One-dimensional arrays. So an array is composed of multiple elements of the same type. It's made up of elements. Each element has an index, which is its position in the array. Those are these terminology, I guess. Memory layout. An array has a fixed number of elements. The elements are numbered from 0 to n-1, and they are packed in memory. So there's no empty memory in between them. Looks like this, right? They're arranged in memory from 0 to n-1 and then packed together. Okay, we define an array using these brackets like this. So type, and then the identifier, and then in the size, this must be a constant integer expression. You can't have a variable there. Here's an example. This has to be constant. We can create arrays of any types, like enums or class objects and so on. Okay. This is legal because size is constant. This is not legal because length is variable. Subscript operator is used to access an element in the array. Syntax looks like this. Left-hand operand is an address. The right-hand operand is an index, which is an integer expression, not necessarily constant. And it evaluates to the value of the array at the specified index. Okay, you use it like this, right? Just like you've seen in many other programming languages. You do this, right? The value can be any expression. The name of the array by itself, score, if you use it just by itself, is the address of the array, or the beginning address of the array. Okay? So like this, right? This is the first element in the array, this is the beginning address of the array. You can't use it without anything in the brackets. Okay, wonderful. Let's look at this for a second. We won't do the simple ones, but we'll do the complex one. So we do this, 4, 1 to 9. What happens if we did this? Scroll up so you can see the demagnify this. Okay. So what would happen if I did this?
I will just accept it. I think it depends on the compiler if it's checking for the array size. I think
Okay.
here.
And if it's not?
I think they don't.
Yes, there is even a runtime error.
Maybe. Maybe not. You might never even notice.
I think it's up to the compiler.
Yeah.
If it doesn't give an error, but it will assign, it will allocate some, memory space with that number. Is that it?
Yes, it will happily, by default, it will happily write the value of 8 into this location of memory here.
And there
But
might be some other variable there.
there might, yeah, you don't know what's going on there. So that's about this bounds checking. C++ does not do bounds checking. You can add in packages which will do bounds checking for you, but by default, stock C++ doesn't do it. So, okay. So what happens? The result is undefined. Great. So if the memory belongs to another application, the operating system will abort your program. That's a segmentation violation usually, right? That's fun. You might get a different error message depending on your OS. And if it belongs to your application, you might modify some other data objects. So that's why you should always check your indexing, right? You go from 0 to 99, not 0 to 100. Fine. We can initialize an array using an initialization list. This is just like we did for structs. Okay, curly brace with a comma separated list. So there's lots of rules here. The size is optional. If you don't put in the size, it will figure out the size for you, the minimum size you need. This is initialization, not assignment. So you can do this during initialization, but you cannot use this kind of syntax for assignment. Just by the bar, not allowed. Okay.
One
Yeah.
question. When you say memory, do you mean RAM or what will happen if your computer uses some paging that's access to the hard disk?
So if you're, for normal application programming, if you access memory which belongs to your program within your program's address space, but is on disk, the OS will halt your program and put you on a waiting queue until it fetches the page from disk and puts it into RAM. And then it restarts your program where it left off, right? And all that's transparent to you. So it makes no difference about swap. Does that answer your question?
Not really. So let's say MATLAB uses paging, right? You can create if you have 64-bit machine, you can create unlimited data space.
Yeah.
So let's say you occupy all of your hard disk with a single variable. Then you do some, error and you made a mistake and assign another memory. But that will still be inside MATLAB, which will not be on your lab, but it will be on your hard disk. So is that still a memory? Is that?
Yeah, I mean,
Is it-
if it belongs, yeah, that in my way of thinking, that's memory that belongs to your application.